Next on, Mikhail Rozhkov is the solutions architect and founder of machine learning Repo School, joining us from Serbia to present his talk, DVC in machine learning engineering and MLOps practices.
Thank you very much.
You're welcome.
Hello, everyone. Good afternoon, ladies and gentlemen. Let me introduce myself and present my talk today. We'll talk about DVC and MLOps practices. And after my talk, during the question session, I really like questions. So for the best question, I have a gift. And gift is not this red bag, but thanks to Poslovna Inteligencija and Bird Consulting for the bag, it's very useful. I'll put it here. Okay. And what we are going to talk about today is DVC. DVC is a very interesting tool that I use for around 4 or 5 years already, and I use it in different projects. And also, we'll talk about MLOps. So what kind of features, so actually how DVC works and how it can help in your machine learning projects, and how specifically it can be applied for different machine learning practices and engineering. So we'll jump to these MLOps practices later on. My name is Mikhail Rozhkov, and I am a machine learning engineer and consultant. And the last 2 years, I had a chance to work with Iterative AI company. Is a startup that develops tools like DVC, CML, GTO, and others. And in the team, I help different companies in the United States and Europe to design machine learning solutions and MLOps platforms built on open source tools. So I help them integrate DVC and other tools into their ecosystem and make it work. Also, a few years ago, we founded open community. We call it MLRepo. And this community stands for Good Engineering Practices and MLOps practices. And like everyone are welcome to join our online meetups, of course. And I also had authored few tutorials and online courses about DVC and other tools and different use cases for integration. So let's start with a question. Why should we invest in MLOps? Previous speakers today discussed different aspects of machine learning engineering and practices and different tools, and all of them are very important, and it's like a good background to my talk, so thank you very much. And let's dive into MLOps. So MLOps is a set of standardized processes and tools that help you to deploy and operationalize your machine learning models and make it rapidly and fast. So I took this definition from Practitioner's Guide for MLOps written by Google. Sorry for typo there. And I like this definition because it doesn't narrow the definition of MLOps only for deployment and DevOps practices. So it covers whole process of machine learning development and all machine learning lifecycle, from development actually to monitoring and having this back loop. So every data initiative, ML initiative, starts with data engineering, right? And we had a lot of, Anthony told a lot about how it works and what we need to prepare the data sets and prepare features to train the models. And the second step is actually machine learning engineer. We take this data, we extract features, we train different algorithms, we get the model as a result, and this model we use in some system or process. And here, actually, where we get this value from machine learning, right? We need to integrate this model somewhere, make it work, get prediction and use it for business process, and constantly monitor how this model works. So having this feedback loop from the model to be able to improve it and fix sometimes, because sometimes it doesn't work properly, right? We also heard about this today. But what is inside? Actually, I guess that again, the speakers already presented, so what do we have for data engineering? So we need to ingest data to our systems. We need to create data sets that we use to train our models. And we need to annotate it somehow to define what is target variable, define, I don't know, organize somehow the process how we update data or fix our annotation. So it's more or less standardized for tabular data, but it's quite a new process, and new tools are required for non-structural data like images, videos, and text. So for machine learning engineering, of course, we codify our experiment process into some pipelines, version that pipelines, and then run our trainings and experimentation, and then track the results. And for the engineering step, we need to somehow wrap our model into some deployable package, or inside the Docker container, or inside other format that we can then deliver to the target system, make it work, and generate some money. Okay, so MLOps here actually is some kind of glue that holds all these pieces together, integrate and standardize. And this is how I understand the MLOps, and we need to, when we talk about MLOps, it's just another term of doing good engineering, bringing good engineering practices into machine learning development lifecycle. In 2018, when I started to work with DVC and implemented our project, I already had some experience with consultancy where, for a couple of years, we developed that tool, actually search engine, using neural networks with attention mechanism. And we realized at that time that sophisticated algorithms and start, I would say, sophisticated models that we have on the market, they are not guaranteed the success. And the real success we get when we have a good engineering practices, when we have automated pipelines, and we can able to understand, for example, what's going wrong with the model during the process, and iterate faster to make it work and make it improve. So we came up with a few principles. Now we can summarize it as a reliable ML. So our model should work robustly. It should be reproducible. We need experiment versioning to version not only the code, for example, but also understand what version of data we use to train this specific model, and which set of parameters we use to train that model. And the third one is a pipeline as a code, right? So we can design or write a prototype in Jupyter notebooks and run it manually, step by step. But it's not robust. And usually it does the work when you just give your Jupyter notebook to your colleague, and usually they have some problems to run it, and or they can get another results. And this is what pipeline as a code principle means. Let's wrap our model training workflow into some codified version, actually store into some pipeline that we can just run using only one command or one button, and we can reproduce the whole process by that one command in different system, in different environment. And the last one, of course, and maybe the most important here, is automation. So it's not fun to do the same manual work on every project, I don't know, every day. And if we can automate something, so let's automate it. Just automate and forget, and it just works. So from these principles, we can come up to some good practices for MLOps. For data engineering, we can talk about data automation and data versioning, and actually, so data versioning we'll discuss a bit later in context of DVC. We can create some data registries for data sets that are commonly used to, like, reusable data sets for different projects. It's sometimes very common scenario for banking and telecoms, when we need, for example, we need to train the model that predicts some demand on specific product, and we use the same data, the same features for the same customers. We only change our target variable. So from one product to another, etc., like sales for that product, of course. And it doesn't make sense to calculate all the features we need every time. It makes sense to create some data mart or feature store, put that features there, and let people to reuse it. So it will speed up the process, the development and deployment process, that will reduce the cost for infrastructure and computation resources, et cetera, et cetera. So we can gain a lot of value from this. And also, like during this process, when we're trying to do something, some reusable asset of data, we put more attention on engineering practices. We try to make it robust and automated, and it brings us, like, we usually can find and fix a lot of bugs during this process. So for machine learning engineering, of course, it's everything about automation. So we just automate our pipeline and then run it, and model registries. And for engineering, app engineering and deployment, of course, it's CI/CD. So all the process of deployment should be automated, including monitoring. So how this affects the business? Actually, the MLOps, when we can automate everything, reduce the time to market for our model. As faster we can make our model run and generate value, the faster we'll get the value from the model as some money, right? And if you try to calculate, I don't know how much benefits value some model bring to the business, you can estimate how much money we'll lose if we postpone the deployment or integration to the 1 week or 1 month. So for large companies, it could be hundreds or maybe millions of dollars. And of course, if we are doing this process right, we can reduce our costs substantially. So we don't waste computational resources, we don't waste our team time, and so we reduce the risk that our model in the production will not work as expected. So this is the value of MLOps in ML projects. So let's jump into the DVC and try to understand how DVC can help us with all of this. So DVC is an open source library that actually brings functionality to version your data and models and automate machine learning pipelines. So let's start with versioning, so how it works. Let's imagine that we have a train script that generates our model, right? And if you want to start versioning that model and data, you can run the DVC add command that will actually take the model, put it into the local data cache, and create some metadata inside your Git repository. And you actually need to commit this metadata to your Git history and store this metadata in your Git, right? So by doing this, you connect, you connect data history and code history inside your Git repository, and you don't need any cert tool or cert system. And then DVC manage this data separately. It can push your data to the remote storage. It works with different clouds and with different protocols, with the clouds or with on-premise storages. So DVC pushed this data to the remote storage, and Git pushed that updates to your remote Git repository, like the GitLab or GitHub. So it means that like we store data in specialized data storage, and we keep only metadata in our Git repository. And this is how, like, for example, DVC, different from Git LFS. It keeps all these things differently. But by using that metadata, DVC can understand which version of the data set or model is used to, for this specific version of code, and can bring it back when you need. So this process actually supports team collaboration. If your colleague wants to get the results you just achieved, it should just clone the repository to his workspace, to his machine. And so he needs to run the git clone command, run git checkout to specific branch or specific commit, and then run DVC pull command. And DVC will bring this data to his machine. So this is how DVC versioning works. It's applied to data and models. And it better works with non-structural data when you store your data in files format. But it also, there are some workarounds to make it work and beneficial with a table of data as well. So let's jump to the pipelines. DVC also brings like this pipelines functionality where you can take different computational tasks and prepare a simple configuration file in YAML format that just order different, not order actually, but just has a list of stages. For each stage, you need to specify name and command that you need to run for this stage. And by doing this and by specifying inputs and outputs for each stage, actually DVC understands in which order it should run this pipeline, your computational tasks. What is good that you can run different scripts in different languages. So it's a language agnostic tool. Inside your scripts, you can use any machine learning framework, scikit-learn, PyTorch, TensorFlow, whatever. So DVC doesn't know anything about what is inside your scripts. It only takes care about inputs, outputs, and the computational duck that it runs. And here is another interesting feature. You need only one command to run the whole experimental pipeline from the start to the end to get your model and model evaluation report, DVC run. And the magic here is that DVC doesn't run every stage when you run this command. It means, for example, if you run the whole pipeline, and then on the train stage, you change some parameters, like learning rate or something like that, or name of algorithms, DVC will understand that only parameters or, let's say, dependencies for this stage, train stage, has changed, and will rerun the pipeline starting from this stage. So it will take the outputs from the data load and feature extraction pipelines because they didn't change, and we can reuse that results. So this feature actually can help to speed up the training process and reduce the cost for computational resources. So another feature is experimental management and metrics tracking. So if we can run our machine learning experiments with DVC, why not track the metrics with DVC? And DVC has this feature as well. So basically, it's a command line interface, so you also can run some commands like DVC show to print the metrics from your experiments inside your terminal. And you can do like, there are some additional arguments, right, to make it work and to see what you like. But if you don't like command line interface, you may use extension for VS Code. And this extension actually is UI to managing your experiments, to run your new experiments, and do this experiment comparison. So inside your VS Code IDE, you can see these tables with different experiments you run, with different compare metrics and parameters, and even visualize some plots for your metrics, etc. And another feature here, actually, it's not visualized on the slide, that when you run multiple of experiments, and for example, later you'll compare different experiments and decide, okay, I want to pick up that specific experiment I ran 2 days ago and save it, persist it in my Git repository, and save model to the model registry. So DVC can just make it happen using whether this DVC xpush command or some similar command inside UI. So it just extract the results of that experiment from the history and bring it back to your workspace. And after that, you just do git push and DVC push, and you persist the result of your previous experiment. Okay, so this is what is called experiment versioning, when we version not only code, but we keep versions of code, data, and models and make them aligned together. Okay, let's go to MLOps practices. As you see that the feature we discussed already, they are more or less about different practices that we can already use it in our projects. But today I want to just stop on a few of the use cases that are not not obvious, maybe not common, but they are quite interesting. First one is a model registry. So because the model is a file, and DVC works with different files in the same manner, so we just version it. We can version our models with DVC. So just ask DVC to put it into remote storage and create the metadata that we can keep in our Git repository. And it's fine, so we can just create some tag, for example, git tag, and push that git tag to our repository. And inside Git repository, we will have all the information about versions we have. But the Iterative also designed a new tool named GTO, or Git Tag Operations, that simplify this work. And it can helps you to register new models, create specific tags for your models, and save them in your Git repository. And that tags are actionable, so you can, for example, register new versions. You can assign different stages for your model. For example, this model is for development stage, that one for production, etc. And using GTO, you can easily understand which models on which stages at this moment. And you can download, upload that models, and use this technique to automate your CI/CD pipelines. So another one, CI/CD. What we can do with DVC and CI/CD is automating the whole training processes, right? For example, we need to retrain our model every week or every day. What we can do, we can just run DVC xrun command inside our CI/CD pipeline as a separate job. And it means that the scheduled job will create some instance in the cloud or in your local machine, run the new experiment with new data on new set of features, and persist the results in your remote storage. And that's it. So you can fully automate this process, or you can, after the retraining your new model, you can create a pull request and like request a manually review and accept that request. And using another tool like CML, you also can integrate the model training reports inside your Git or merge request command. So you can see the model training evaluation report inside your Git repository and easily understand should you merge that changes or not. Okay, and the last thing is availability of integrating the DVC with different other tools. Recently, we had a demo where we integrated DVC with Evidently AI. So DVC was responsible for automation and versioning, and Evidently AI is a monitoring library, just calculated different metrics and reports for us. So we designed a separate pipeline that runs more prediction, like a batch scoring prediction, with DVC, then generating new reports, and DVC will preserve that reports and save them into remote storage. Actually, that's it from me today. So I use DVC like for around 4 years already, and it nicely applied in different use cases and scenarios. Table data, the computer vision, et cetera, and for me, it's like a Swiss knife that I can use like as a, I don't know, basic tool just when I need to solve some specific engineering task. So it's quite flexible and powerful. So if you want to know more about this stuff, you can check our MLRepo library. This is a set of tutorials that a community develop and save in GitHub repository. So you are open to join, review, contribute, etc. So I guess that's it from me, and thank you very much, and I'm happy to answer your question. Yeah, please remember that we have gifts, so questions.
Thanks for the talk. What would you say, what are the main differences or advantages, disadvantages between, for example, MLflow and DVC? So you are pushing now a lot DVC. What would you say about that?
Yeah, great question, thank you. Like MLflow is, like what a difference? To use MLflow, you need to run MLflow tracking server somewhere, right? And somehow manage permissions for users to push the new metrics there. And if you like solve this, it's fine. But with DVC and DVC extension, you actually don't need to do this. You can see all your metrics inside VS Code directly. It's like, yeah, so all team can just pull your repository, and inside VS Code, they can see all that metrics. So for like, okay, so for basic scenarios, it's enough, I would say. This is, okay, sorry. This is the first difference. The second one is that DVC follow this GitOps approach, and MLflow has a limited functionality for this. You can like make it work with support, like make MLflow support this GitOps approach. We even integrated for some customers DVC and MLflow. They also can work together. So it's, let's say, only, so in different scenarios, you will just prefer different setup. Only DVC, only MLflow, or some kind of integration.
So, hello? Okay. Summarizing, DVC is a bit easier to set up and maybe maintain, and MLflow might be a bit more complicated.
Actually, it's all opposite, and this is another good question.
I didn't get the point.
Yeah, like DVC just needs more, like the learning curve is steeper. I would say for DVC it's more technical. For MLflow is easier, but there is another tool named DVC Live that behaves the same as MLflow. I mean, you just import that DVC Live into your Python code and log some metrics and plots. And this make life easier. Actually, it's experience very similar to using MLflow.
Thank you.
You're welcome.
So I just wanted to ask, this kind of implies that the workflow is very, well, extremely fork heavy, as the data to code relation is usually many to one, especially relating to evaluation sets, for example. Does that, I mean, how does that work in practice? Because as I said, you often need to, you often inject data into the code much more than you alter the code itself.
Can you elaborate a bit your question and maybe
so
rephrase it?
my friction when I tried with DVC is, yes, I wanted tracking, yes, I wanted artifact management, yes, I wanted all of that, but I wanted to manage the data versioning and the code versioning, but working them together is kind of weird because I changed the data much more than I changed the code. And for example, if I wanted to evaluate 20 different data sets variously sampled or whatever. And with sort of vanilla approach, how you would do it, you would need to like make a fork for each of them, register each evaluation set change, and it would get very fork heavy. That part is a bit difficult to manage.
Yeah, thank you. It's also a great question. Yeah, in the example, I showed you that you have like data preparation and training in this single simple pipeline, right? But for heavy data project, it makes sense to separate them. So you may have a separate pipeline for data preprocessing, and you may use DVC only to version your data, right? Or whether using just DVC add commands or creating like a separate pipeline, but specifically for data. And then for your machine learning pipeline, you can just import the data. So DVC can these commands to just get this data for your to your machine where you run the experiments, and it will work. So this concept also known as data registry. So you can register your data sets, and also inside your ML pipeline, DVC pipeline, you can, for example, have some kind of loops that runs a stage against different data sets, like 20 data sets as you mentioned. So different scenarios are possible and for such use cases as well.
Okay, we have to continue. You can ask during the lunch break. Thank you very much.
Yeah, well, so sorry, and yeah, the good question. Actually, I think we have the two good questions, right? So both of you will get a gift. And the gift is a T-shirt, like that me and my wife designed specifically for you. So this like. So thank you for your questions.
Thanks for watching. If you enjoyed this community spotlight, please like and subscribe. Thanks, Stevie. And feel free to post comments and questions below. Beyond our tools themselves, we have many resources for you on your ML journey. Visit our docs, our blog for tutorials, our YouTube channel, our Discord server for support and community, and our free online course. You can find all the links to these resources in the description. Thanks for making it to the end. DV and I will see you in the next video.